Hello, networking enthusiast. Welcome to the channel God of Networking. Today, I will show you how to configure BFD in SONiC. As we know, in SONiC, by default, all ports are in layer 3 and all ports have been assigned default IP addresses. So, before starting of the video, I have removed all the IP addresses which were default and assigned new IP addresses that I have to use in my topology. Now, this video has two steps. In the first step, I will configure OSPF on all routers and check the convergence time. After that, I will apply BFD and again I will check the convergence time. Now, first of all, I will go into R1. As we know, the architecture of SONiC is designed in such a way that FRR is integrated in SONiC. For all L3 protocols, we have to use FRR commands. First, we have to go into BGP container and then start a daemon process which will run in background. Now, first of all, I will run OSPF daemon in the background by using following steps: docker exec it bgp dash cd/user/lib/frr ls OSPF daemon. And now here we can see OSPF daemon is running in background. Since it is a redundant work and same set of steps I have configured before starting of the video. So now I will show you R2. As we can see, before starting of the video, I had already started daemon of OSPF. Since it is a redundant work, to save time, I have done all these kind of things. Now R3, as we can see here in the R3 as well. Now again I will go into R1 and configure OSPF step by step. Exit Vitish configuration mode router OSPF. Now I will advertise all those networks which are directly connected with R1: 192.168.10.0/24 area 0, which is called backbone area, router 1, 10 and 11, 10 and 11. Exit right. Now I will go into R2 and repeat the same steps. Exit Vitish configuration mode router OSPF network 192.168.10.0/24 area 0, 10 and 12, 10 and 12. So I have advertised these two networks. Exit now right. Now again I will go into R3 and repeat the same steps. Vitish configuration mode router OSPF network 192.168.11.0/24 area 0, 11 and 12 are directly connected with R3. So exit route. Now I will check the status of OSPF in R1 using command show IP OSPF. As we can see here, OSPF has been configured in R1 without any. Now I will check the status of neighbors. Show IP OSPF neighbor. As we can see here, neighborship has also been established. Now I will go into R2 and check the status by using command show IP neighbor. Show IP OSPF neighbor. As we can see here in R3 also neighborship has been established. Now I will generate a ping request from R1 to R2. Ping 192.168.12.2. So as we can see here, R1 is getting reply from R2, and the interesting thing which we must see is that TTL is 64. What does it mean? It means R1 is getting reply from R2 through this interface. Actually, R1 has two interfaces, yet two paths for reply. one path is here and the second path is this, but it is getting reply from this path because it is acting as a shortest path because TTL is 64 and it is not decremented. Now I will stop ping request and I will suspend this link and will check the convergence time of OSPF. Now again I will generate a ping request. As we can see here, R1 is not getting reply from R2. As we know, default downtime for OSPF is 40 seconds, which is equal to 4 times of hello packets time. Now, as we will see, after approximately 30 to 35 seconds, R1 will start getting reply from R2 because after 30 to 35 seconds, R1 will get reply from this path. As we can see here, R1 is getting reply and the TTL has been decremented by 1. It means R1 is getting reply from this path. Now I will start a Wireshark here and capture packets. As we can see here, request as well as reply, both functions are done through this path. Okay, now I will stop Wireshark and again I will resume this link. Now the second part of our video is that BFD. After configuring BFD with OSPF, this downtime will be reduced to fraction of seconds. Now I will go into R1. I will make BFD peers R1 and R2. They both will act as a neighbor. Now again I will start BFD daemon. Docker exit it bgp bash cd /user/lib/frr BFD. Now here we can see BFD daemon is running in background. Now same steps I will repeat on R2. Exit docker exit it bgp bash cd /user/lib/frr ls BFD. Here we can see BFD daemon has also started and it is running in background. Now again I will go into R1 and start configurations. Itish configuration mode BFD peer 192.168.10.2 exit. Now interface Ethernet 0 IP OSPF BFD. Exit. Now I will save configurations using write command. Now I will go into R2 and repeat the same steps. Itish configuration mode BFD peer 192.168.10.1 exit interface Ethernet. Which interface it is using? Ethernet 0 IP OSPF BFD. Exit right. Now I will check the status of BFD in both routers. Show BFD peer. As we can see here, BFD neighborship has been established. Peer 192. It is showing router 2 is the peer of router 1 ID. This is the local ID of R1. Remote ID is the ID of R2. And the status is up and we can see here everything is fine. Now I will also check BFD status on R2. Show BFD peer. Here we can see everything is fine. Now I will generate a ping request for R2. Ping 192.168.12.2. As we can see here, TTR is still 64. It means it is getting replies from this path. Now I will stop this ping request, and now I will suspend this link and check how much time will it take to converge. Again, I will generate a ping request. As we can see here, within fraction of seconds, OSPF is getting reply. R1 is getting reply from R2, which means this convergence time has been reduced to fraction of seconds, which is the main goal of our video, that how will BFD work with OSPF. Now I will stop it. Now I will show you the configurations file. Again, I will resume it, and now I will show you the configurations file. Exit docker exec it bgp bash cd /etc/frr cat bfd. Here we can see the configurations of BFD have been saved in this file. And now I will check the configuration file of OSPF cat osp.com. Here we can see. So thank you guys for watching my video. If you want more videos like this, kindly subscribe my channel.